In our previous video, I showed you how to visualize and set up your question for part A and B. I left you to solve the problem, and the solutions are available for you here for R, T, and M. And now for part C, when the particles have been moving for 0.5 seconds, the string breaks. Now my advice is when you do these types of questions for subsequent motion, you sort of try and sketch what's happening. Okay, so when you start off with this problem, t equals 0, and just draw very rough sketches of what's actually happening. So you've got your particle here, okay, that's particle P, and this is particle Q, which I'm going to draw here for you, and you've got something like this. This is a very, very rough sketch of what's happening. That's t equals 0. And then, when it's been moving after 0.5 seconds, so when t is 0.5, okay, it's been moving, and then something's happened. Okay, what's happened? The string's broken. Okay, so how would I represent that? I'll say, okay, let's say it's gone up here somewhere from your initial starting point, which was there. Okay, and this guy has gone down from your initial starting point somewhere here, and you've reached this situation. Okay, so we've reached this situation where now you're here somewhere and the string's broken. So this string has completely broken. Okay, I'll represent it as a dashed line. And that's at t equals 0.5 seconds. And now let's carry on reading. Assuming that P does not reach the pulley, find the further time that elapses until P comes to instantaneous rest. So after 0.5 seconds, this particle is still going to want to carry on moving up. We've been told that the particle does not reach the pulley, so it's going to reach here somewhere. Okay, and this guy is sort of broken already, so it's fallen down, so I'm not going to worry about this particle, because once the string, so here the string breaks. Okay, that string breaks, and then this is after string breaks. Okay, and here the string is taut. Now we've got to really think about what's happening here. We've got to really think about what's happening here. When the string is taut, you're in this model. And in this model, because the tensions were the same, why? Because the strings are inextensible and light, we knew that the acceleration for both particles was the same. So for the first stage, we know that the acceleration is 1.4, and here that's going down, that's also 1.4. At 0.5, the string breaks. Now what's going to happen at this stage is that you don't have this same acceleration now. Okay, the acceleration is not going to be available for you anymore. But what you do know is that obviously it's going to change. And in the second stage, after the string breaks, the acceleration is going to change as well. So I need to work out what that new acceleration is to begin with, okay, before I can do anything else. How would I do that? The way I would do it is I would look back into my diagram and I would think, okay, I need to create another equation of motion without the tension. There's no tension anymore. You could do this pretty quickly just by using your original diagram, because all you have to do is for particle P in the direction of your original acceleration, I'm going to resolve, and I've got F equals ma. But watch, there's no tension anymore. No tension anymore. So you're going to have minus 0.3 g sine alpha minus a half r is equal to the mass, which is m, 0.3, times by the acceleration. Now in your previous question, you already worked out what r is, so I can sub it in there. And I know the sine alpha fraction is 3 over 5. So I end up with this situation, minus, so sine alpha is 3 over 5. 3 over 5 times by 0.3 g minus half times by r, which is 6g all over 25, and that's equal to 0.3a. If I now just basically divide by 0.3 all the way through, you end up with a equals minus 3 over 5 times by 0.3 g minus a half 6g all over 25, all divided by 0.3, and this will give you your new a. Once you know what your new A is, then you've got something to work with. Okay, so we can deal with that in a moment. But that's very, very important. You need to work out what your new acceleration is. Then the reason why I'm saying that is because to work out when does this particle P come to instantaneous rest, you're going to have to use SUVAT. Okay, you're going to have to use SUVAT. But SUVAT, you will have to use it at different stages of this problem. The final SUVAT you're going to have to use is for when the string breaks, after the string breaks, and that's going to look something like this. The final SUVAT is going to look like this. You're going to have S, U, V, A, and T, and I'm trying to work out when is this particle at instantaneous rest. This is after string breaks, SUVAT. It's in this column, and naturally that's when V is equal to 0. Okay, I get my new A from here, so I know I'm going to get that new A here. That's not a problem. However, I need one more piece of information. I've got the A. Okay, you can work out what the A is, so that's going to be easy. What's it, sorry? What is it, sorry? It's minus 9.8. Thank you for giving me the value. So that A is minus 9.8. And I need one more piece of information. And that piece of information that you need to work out the further time, which is this problem here, is U. Now this is very, very important. It comes up in every question. And this is the reason why I've set it up in 3 stages. That U is going to come from your final velocity at this point of particle Q. Okay? So you need to work out what is the final velocity of particle Q when the string breaks. When the string breaks. Now listen very, very carefully. I can do that very easily. S, U, V, A, and T. Okay? So I've got now your initial velocity for this motion is going to be, it starts from rest, 0. Okay? The acceleration for this motion here is 1.4. So that's 1.4. And you know the time. The time is 0.5. So using U, A, and T, I can work out the final velocity of this part of the motion. And once I work out the final velocity of this part of the motion, that final velocity becomes the initial velocity for when the string breaks, for after the string breaks. And once you've sort of figured that out, you're fine. So can someone give me the value of this V, please? What is it, sorry? 0.7. Okay, 0.7. So that 0.7 would be placed there. And then the final step is to do SUVAT again to work out time. And what's the answer? What is it, sorry? 1/14. Which is what as a decimal? 0.0714. So I didn't go through the working out of the steps, but the purpose of these videos is to give you an idea of what the strategy is. If you've got the strategy, the rest will just follow. Trust the process. Thank you. You know, turn the video off.